Now, I mentioned in the Channel 5 documentary, probably the main argument they used to debunk the people who don't think we landed on the moon was the photo. They said recent photographs have been taken by Lunar Orbiter that's overflown most of the Apollo landing sites and filmed all of the junk that was left behind, the rovers, the flags, and the actual craft. So is that not incontrovertible evidence, Andrew?
Well, you would think so, wouldn't you? And you know, people have made various claims about these images, and we talked about these Chinese images, which have supposed I've not seen those. I've not.
We'll come on to that.
Right. Okay. But this story for me starts probably 4 or 5 years ago when somebody sent me an email and saying, "Well, Andrew, can the Hubble telescope see the images on the moon?" Because everyone's heard of the Hubble telescope. It's a big, you know, space telescope, very powerful and so on. Takes all these wonderful images of the various galaxies and so forth.
So the argument is, all they have to do is point the Hubble telescope at the moon and they'll see everything that's on there.
End of story. Sorted out, you know. Okay. But again, it's not as simple as that, because if you look at the figures, and it's easier than you think to work this out, you know, and we can explain this very easily with a bit of sort of GCSE level trigonometry, basically. And we can say, well, we know the size of the lunar module approximately. It's 4.2 meters across, so we've got an object sitting on the moon. If you're looking at it in plan view, it's 4.2 meters across, basically. Mm-hmm. You can then look at what the distance from the Earth to the moon is, which is 385,000 kilometers. That's sort of an average figure. Obviously, it goes up and down from that because of apogee and perigee and so on. But if we take those as a basic set of figures, you know, you can add a factor of 10 either side of that if you really need to, and this will still show you the answer. And then you end up with what's called an isosceles triangle, and you can work out the angle, because why we want to work out that angle that I've labelled on the diagram is that equates to what's called the resolving power of a telescope. Any telescope that's built, it can resolve individual objects of a certain size, and that size is measured as an angular separation, not a physical size, because the angular size is you know what you actually see, and the physical size varies. You know.
Just to explain that, Andrew. Okay, so if you look at the moon and draw a line from your eye to the top of the moon, and draw another line from your eye to the bottom of the moon, they make an angle. That is the angle subtended to your eye, and each telescope will have that. It's a very, very small angle that telescopes can normally resolve.
Correct.
Can see objects at an angle that small. So the Hubble telescope has a resolving angle. Yeah.
That's right, and you can check out what that is. You know, you can find that information. It's measured in seconds of arc, because as people probably know, a circle is divided into 360 degrees, and then each degree is divided into
60 seconds,
60 minutes,
and then
each minute is divided into 60 seconds.
Right.
So in each degree you've got 3,600 seconds of arc, and you can look up the Hubble's resolving power, and it comes out at 0.05 seconds of arc. So that's, as a fraction of a degree, that's 0.05 over 3,600. So it's 1.389 times 10 to the minus 5 degrees is the resolving power, if you will, of the Hubble Space Telescope. Or depending, we have another figure which I found, and that came out as 3.89 times 10 to the minus 6 degrees. So that makes it even more sensitive. You know, it can resolve even smaller objects. Right. But if you do the calculation for the lunar module, you come out with a figure of 3.3, or rather 6.26 times 10 to the minus 7 degrees. So the angular size of the lunar module on the surface of the moon is 6.26 times 10 to the minus 7 degrees.
And that's a factor of 10 times too small.
Correct.
For the Hubble to be able to see.
Yeah, correct. Right. So it's 10. Essentially, it's actually about 20 times. Right. Yeah. But,
so if the lunar module was, say, 30 times bigger, then it would be able to see it.
Right.
But it can't because it's too small.
Correct.
Okay.
Correct. According to the figures that I've been able to work out, and obviously, if there's any viewer, you know, that finds an error in these calculations, they've been up on my website for several years, and I had one small correction, but it was only by a factor of 2, which didn't affect the factor of 10. So if anybody finds an error, that I'd welcome any criticism of that, you know, of any part of that argument. So in other words, all we can say is that Hubble's no good, can't do it with Hubble, and so we have to look at something else.
Right. So NASA brought out these images of all of the remnants of the Apollo missions.
Correct.
All right. So case solved.
That's right. Of course, NASA had what's called the Lunar Reconnaissance Orbiter. I talk about this in this presentation that I put together, and that was launched June the 18th, 2009.
Well, just hold it there, Andrew. We're going to go for another break, and we'll be looking at NASA's alleged images of the Apollo relics after this break. Welcome back. I'm with Andrew Johnson, and we're going to look at some images put out by NASA which allegedly show the remnants of the Apollo programs taken by Lunar Orbiter craft. In what year did you say, Andrew?
Well, what happened was in 2009 the Lunar Reconnaissance Orbiter was launched. It had a high resolution camera, sort of better than the previous one, and I think the original mission for this was to look for new landing sites for the new moon mission program, which was announced some years earlier. Now it's all been scrapped, and we'll mention that again later. But so Lunar Reconnaissance Orbiter, everyone said, oh, we're going to get these new high resolution pictures of the moon. We're going to fly over the old landing sites. We'll be able to see the craft, and that'll prove all these crazy conspiracy theories wrong. So these were images awaited with great fanfare, and finally, I think it was the 11th of August 2009. Sorry, 11th of September, I think it was actually when these came out. 2009. Yeah, it was an interesting date. Was it the 11th of November, or it's 9/11? It was 9/11 date anyway.
Yeah.
And what we see on NASA's website is the supposed picture of the Apollo 11 site, and the Apollo 11 Lunar Excursion Module, the LEM, is shown as basically a sort of reasonable sized white blob with 3 and a bit white blobs around it. And you can see this
sort of the feet.
The feet, exactly.
Right.
Feet of the actual the landing part that they left on the moon. So basically with this,
and there's a scale on there.
There's a scale on
their image.
Correct, and they give you this figure of 200 meters. So when you look at the space between these dots, which is meant to be the feet, of the Lunar Excursion Module's landing section, you can then work out how big this distance is, because they give you a scale. So this is what I did. I worked this out. So I found out the size of the distance between the feet, which is of the Lunar Module Excursion, Lunar Excursion Module, and it's 31 feet. Diagonally across.
Along the longer length, yeah, okay.
Right, so if you plug that into the figures that NASA gives you for the size of this image, that Lunar Excursion Module landing section should fit into a space at 7 by 7 pixels on that image. 7 by 7 pixels. That's the figure you come out with. Or maybe it'd be 8 by 8,
okay,
possibly 9 by 9 or something. You could maybe slight margin of error, something around that figure. So when I actually measured what this alleged photograph shows, and I measured the distance across, it's basically a distance of about 28 pixels.
Right.
Which means
so it's a factor of 4 too big.
Roughly, between 3 and 4, depending on how you sort of turn the image and so forth.
Right.
But
so it's completely the wrong size.
Yeah,
the image
so it's the wrong size. It's the wrong size.
And we were talking about UFOs.
We were.
And
funnily enough,
let's say I brought out an image. I had someone on the show who was eulogising about an image.
So let's say it was taken from a helicopter.
Yeah. Hey Richard, I was in my helicopter the other day and I filmed this UFO. It's phenomenal. Look at it. Look at the picture. And if they showed that, what would people say? Exactly.
If you showed that as an image of an alleged UFO that you took and you didn't have anybody else's photograph of it to back you up, would you believe that was a metal object resting on the ground below you? Would you believe that was a real photograph?
Yeah.
People will believe this because it's on NASA's website.
Yeah. Because NASA say that is the real. Apollo 11 craft, then people believe it is.
Yeah, exactly. But if you look at the quality of that image and you study this, I don't know whether this will come out on the video.
As you say, it's a white blob, Andrew. Could be anything.
Right. And then you look at these other, and then what I tried to do is I tried to get an impression of what it should look like, and I managed to find, this isn't again a totally realistic image because we see the lunar module in orbit rather than landed, but I tried to get an impression of what we should see on that LRO image, and
by resizing it
to a 7 by 7 pixel image, or a 25 by 25 pixel image, which is the size I calculated it to be, and then I compared that with the NASA image, and there is you know, it just doesn't add up.
If you compare it to Google Maps or Google Earth,
Right.
which a lot of people are familiar with now, it's pathetic.
It is. Now, we've got to be careful here, because I actually made a mistake with this part of the analysis originally, in that, yeah, we look at the Google Earth images, and but some of those are not from a satellite. Some of them are aerial photographs.
Right,
The
Google
ones that
Earth.
are lower down, yeah, the Google Earth ones. Some of them from aerial. Some of them above
From
a
a
certain
plane,
height are
yeah.
from a satellite,
Right.
and some are from a plane. But we do have a comparison with GeoEye, and this is something that J.R. White has done. He's another researcher that's posted quite a few videos about this. And we have a GeoEye image, which is essentially the same resolution as the Lunar Reconnaissance Orbiter.
Just to stop you there, Andrew, GeoEye is a satellite which goes around the Earth and takes photographs.
Correct,
Okay.
correct.
At a particular height or distance.
Yeah,
Right.
yeah. And I mean, you know, I think they've got their own website and stuff. I think they sell these images. I don't think this satellite is owned by NASA. I think it's privately owned by a consortium or something.
So he's compared images of Earth taken by that satellite with images taken by lunar orbiters.
Right, and I think that because the image resolution is comparable according to the you know the information
You
given by
should get
NASA.
the same level of detail.
Same level of detail. So in this particular example, we see a GeoEye image, and you can actually see a car on the road, and you can see with some, you know, you can see it's in colour. You can see the colour of the car.
Yeah.
You can see that it's maybe got a white bonnet or a cream bonnet or something, but you can see that it's, you know, you can see that it's an oblong shape, the right shape for a car and everything, and you can measure it and work out the size. So why haven't we got? And there's none of these vertical grainy lines either. If you look at those LRO images, they've got these vertical lines in them for some reason, which I don't really understand what those are. So if you compare these two images,
Why isn't it in colour for one?
why isn't it in colour? Why? And the same goes with the images from Mars. Why are we still predominantly getting
Yeah.
black and white images?
Well, we'll come on to Mars.
to that. So, but that going back to that. So why have we got such rubbish images from LRO?
Yeah.
Yeah, the ones from GeoEye are pretty good.
Yeah.
You know.
So the first one that they put out, allegedly of Apollo 11, it's just a white blob, and it's completely the wrong size. It's 4 times
Yeah.
too big.
Right.
Now, what about the other images? Because they brought out other images of the other Apollo landing sites.
Right. And in fact, on this particular slide, we've also got a couple of things. We've got, I think this is on the bottom right here. We've got the Apollo 16 lunar module, which you'll see looks different again. We've got this sort of, it looks like it's exploded. We've got this black smearing around it. And on one of the other ones, we could dig this up as we go through it, but if you look, I think the latest images, it does look a lot better. They've actually made it look like a lunar module now. I didn't check the size of it because that came out after I put the original presentation together. I think they did another image in 2011, around about that sort of time, possibly early 2012, and they've improved the look. It looks more like a real lunar module now.
Right.
But here we see the lunar rover parking spot. On the right here, this is their label. This is what they say. We've just got this black smudge with a few white dots next to it. That according to NASA, is the lunar rover vehicle. Which, if if we remind ourselves what it looked like, going back to this slide, we've got the lunar rover parking spot, and it's a black smudge.
Right.
What's that about?
Right.
Is that really become that? I mean, does this make any sense? It certainly doesn't make any sense to me.
Yeah. Why is there a black zone around what looks like this solid area in the middle? What's the black zone? Presumably it's shadow, but shadow wouldn't be cast like that. You wouldn't have thought all around it.
No.
It looks a bit strange.
It does.
So you would contend that all of those images are bogus then?
I would contend that they must be bogus. Yes.
Right. I've heard 2 different stories about the Chinese images, because they are alleged to have had a lunar orbiter. Is that?
I believe so. Yeah.
Right. So I heard initially that they'd brought out images in, I think, February 2012, but I had an email from somebody saying, well, actually, why haven't they released them for public viewing? So I'm not sure whether the Chinese images are available, but they're alleged to be extremely high definition. So maybe we can check that after the show and just put a caption on as to the status of this.
Right.
People would say, well, if China have seen them, then then they're obviously there because China represent an independent adjudicator, if you like. This is one argument that I always use as to why I'm ambivalent about it. I don't get caught up in the argument of whether we landed or not, because there was no guy with his clipboard stood there on the surface of the moon watching the thing come down going, yep, tick, landed, tick, like they do in the national lottery. They have a guy there with his white gloves on, an independent adjudicator. Where is the independent adjudicator in the Apollo landings? We've got NASA's word. Hey, China is the independent adjudicator, but hang on, is China independent? Which was a comment that Judy Wood made in the previous show.
Right.
Do we believe that at some level countries are actually acting independently, especially with pertaining to space, or is there some overarching agenda? There's a lot of information that Andrew has on the moon landing, so we're actually going to film a second show.